The producer is always right.
Oh, I don't know about that.
NASA's Fermi Gamma Ray Space Telescope has observed something it's never seen before. A discovery that helps explain an astronomical mystery. Supernovae are exploding stars. They most often occur when the core of a massive star runs out of fuel and collapses. But in the past couple of decades, astronomers have found supernovae up to 100 times brighter than usual. The mystery is how these superluminous supernovae were powering up. Astronomers looked at 6 near-superluminous supernovae to occur during Fermi's mission. Only one, in 2017, shows evidence of gamma rays, the highest energy form of light. Analysis of these findings clearly favors one explanation. The extra power comes from a spinning, supermagnetized neutron star called a magnetar, formed in the star's collapse. The magnetar's intense magnetic field accelerates particles that ultimately produce gamma rays. At first, the debris absorbs this emission and converts it to visible light, boosting the brightness of the blast. After about 3 months, the debris thins out enough that the gamma rays can leak out and travel to us. With this observation, Fermi has helped solve a cosmic mystery and has added another class of gamma ray sources to its repertoire.
Saturn's largest moon, Titan, is rich in organic molecules, the carbon-based building blocks of life. It's also the only place that we know of, besides Earth, with large lakes on its surface. But those lakes are made from super chilled methane instead of water. So with its abundant organics and its oily lakes, could exotic life forms be brewing on Titan? Well, in 2017, NASA scientists discovered that this moon's atmosphere contains acrylonitrile, an organic molecule that is attracted to both water and oil. Scientists think that such amphiphile molecules could cluster together within Titan's lakes to form hollow, double-layered spheres called vesicles. These vesicles strongly resemble cell membranes on Earth, making the discovery of acrylonitrile exciting. But in 2020, a follow-up study determined that vesicles would be unlikely to form on Titan without an additional source of energy, casting doubt on their emergence. Now, a new study co-authored by NASA shows that the missing spark could come from rainfall. Here's how the process works. In Titan's upper atmosphere, methane and molecular nitrogen are broken apart by sunlight and recombine into amphiphiles. Rainfall transports the amphiphiles to a lake, where they form a thin film on the surface. Later, strong storms pelt the lake with large raindrops, throwing up a spray of methane droplets coated in a single layer of amphiphiles. As the droplets fall and sink through the lake's filmy surface, they receive a second coating. And voila! Vesicles. If they do exist, Titan's vesicles would likely have a range of different chemistries, some more stable than others. Over time, the most stable compositions would build up in an evolutionary process that could lead to the formation of simple protocells. So what are the odds of actually finding these prebiotic bubbles beneath Titan's pond scum? While the new study is speculative, it proposes that a future spacecraft could sail across Titan's lakes, scanning for vesicles through laser light scattering. In the meantime, NASA is already planning to hunt for new organics when the Dragonfly mission gets to Titan in 2034. So stay tuned for future dispatches from Saturn's chilly, oily, and weirdly Earth-like moon.
Earth is constantly bombarded by the solar wind, waves of dangerous charged particles from the sun traveling at speeds over 1 million miles per hour. Our planet's magnetic shield, the magnetosphere, protects us from the brunt of this technology-imperiling force. But high above each of Earth's poles, there's one vulnerable spot in this shield, where solar wind is funneled straight down toward Earth and our technology, the polar cusps.
These solar wind energies can negatively impact power grids, radio communications, satellites, and even astronauts, which is why understanding its mysteries and its pattern is key to protecting our future.
To better understand these space weather effects, NASA is launching a new mission called TRACERS. The two spacecraft will travel through the polar cusps to take groundbreaking measurements of magnetic reconnection, a process that occurs when the solar wind drags the sun's magnetic field into Earth's.
When the sun and Earth's magnetic fields collide, there's a tremendous energy release. The magnetic field lines snap and reconnect, creating new field lines. This process, known as magnetic reconnection, sends highly energized particles in new directions, including down toward the Earth. Reconnection is very difficult to observe directly because it occurs on small scale compared to the vast size of Earth's magnetosphere.
Magnetic reconnection happens in various places throughout the magnetosphere, but it is most easily studied at the polar cusps. When the solar wind slams into Earth's magnetic shield, it's here at the cusps that the impacts reverberate. By flying through the polar cusps, tracers will be able to directly study the signatures of magnetic reconnection, helping scientists better understand and prepare for the impacts of space weather on Earth.
As we understand that and are able to model it, we're able to get more accurate in terms of how we protect against it and then what we are doing in order to mitigate those risks.
Scientists have caught a glimpse of magnetic reconnection in the polar cusps before, giving us clues about this process. NASA's TRACE-2 was one such mission that launched a pair of sounding rockets briefly through Earth's northern polar cusp in 2018.
TRACE took really good data, one low flyer, one high flyer, and it took a snapshot of the Earth system in one state. It proved that these instruments can make this kind of measurement and you can get this kind of science.
The only thing we could not do with TRACE, of course, was to make the measurement multiple times.
One snapshot doesn't tell you how the whole Earth system is going to behave, particularly under all the variation that the solar wind brings us. A long-standing problem with space physics research is if this is the Earth, you fly a satellite through the physics you're looking at and you see something, and then it comes around in orbit later and you see something different.
Building on TRACE-2's legacy, two TRACERS spacecraft will take multiple measurements at the polar cusps by flying in rapid succession, less than 2 minutes apart.
And so with these two spacecraft flying together, we can address this long-standing problem of trying to understand whether the signature that we see of a process called reconnection, when it changes, is that due to something turning on or off? Or is that just that we're flying from one region to another and so we see a change as we transition through that region? People have tried to solve this problem with various combinations of spacecraft, but without two dedicated spacecraft, it remains an open question as to what's going on.
As the two TRACERS spacecraft chase each other around Earth, they'll take a record-breaking 3,000 measurements of magnetic reconnection in the first year alone. These new observations will help scientists better understand and ultimately help defend us and our technology from the impacts of solar wind on Earth.
So not only will it get a global picture of reconnection in the magnetosphere, but it's also going to be able to statistically study how reconnection depends on the state of the solar wind. This is going to really help us understand how to predict space weather in the magnetosphere.
If we can understand in these various different situations, whether it happens suddenly, if you have one particular kind of event, it happens in lots of different places, then we have a better way to model that and say, here is the likelihood of seeing a certain kind of effect that would affect humans.
That was one of our final interviews with Craig. Without him, the mission would simply not exist.
Craig Kletzing, the original principal investigator for tracers and professor at the University of Iowa, passed away in 2023. His legacy as a scientist and avid musician lives on through this mission. 2 of his beloved guitar picks have even been integrated into the spacecraft.
So when Tracers launches, there's a little physical piece of Craig, his curiosity, his ingenuity, and his zeal that will go to space one more time.
What we're seeing here is water contaminated with sulfuric acid and toxic metals, better known as acid mine drainage. And there are thousands of abandoned mines scattered across the American West, each with the potential to release contaminated water into vital rivers, lakes, and water supplies. Now, NASA instruments are providing a crucial solution. By mapping surface minerals from space, they can identify the exact regions in need of remediation. But first, a bit of a science lesson.
The process of acid mine drainage is when rocks that have been underground get dug up and exposed to the surface. When they're exposed to the surface, they are now subject to getting rained on, so they get exposed to water, they're exposed to air, and in that process, they actually convert that water that is flowing over them into much more acidic waters, and they also can release toxic metals.
Now, certain types of rocks do experience this kind of weathering naturally. However, this process unfolds much slower, since rocks make their way to the Earth's surface over incredibly long timescales. But when we extract the minerals needed to power our technologies, these rocks are pulled to the surface at a much faster rate.
And so we really expedite a lot of that weathering in that process.
There are an estimated 50,000 mines across the American West that have yet to be assessed for remediation.
And it can be very expensive to do so on the ground.
Launched in 2022, NASA's eMITS instrument is an imaging spectrometer, a NASA invention that is used to measure light that is both in the visible and infrared wavelengths.
An imaging spectrometer is basically kind of like a really fancy camera. So your camera has, a red, green, and a blue channel, and those are often really broad channels. But light is a continuum, and it reflects at all these different wavelengths. And so if you can measure them in narrower and narrower intervals, you get more and more information about exactly how light is interacting with the chemical surface and the properties of whatever it is that it's reflecting off of.
By using spectroscopy, instruments like eMITS can map large regions to detect mineral compositions indicative of acid mine drainage and its sources. And it's not just for rocks and minerals. Spectroscopy can be used to greatly broaden our understanding of our world.
It's like a Swiss Army knife. There are so many things that people can use it for. We are doing things where people are looking at wastewater, people are looking at surface plastics in agriculture, people are looking at crop heights and thinking about yields.
And as with all NASA data, this information is free and open to the public.
And so we really encourage people to check them out and think about, how they might want to be leveraging them for a variety of different activities.
Packing for a journey to the moon is kind of like any other road trip. You need clothes, food, a map, your favorite toy. Really. Except this toy has a job to do up there because this is a zero-gravity indicator. While not a scientific instrument, this safe and soft object tells the strapped-in astronauts that they've reached weightlessness. For Artemis 2, the crew wanted a one-of-a-kind ZGI, so we asked you to come up with it.
Thanks everyone for sending in your entries from around the world. Over 2,600 of you submitted.
And we loved seeing all of your contributions. It was a really difficult decision because each design had a unique quality that stood out to our crew.
In the end, we were able to narrow it down to a top 5 from Finland, Canada, Peru, and 2 from the United States, Kansas, and California.
In the end, we went with one called Rise. It was a design inspired by the Earthrise photo taken on Apollo 8, which is very special to our crew.
With the winner chosen, next came the task of bringing it to life here in the Thermal Blanket Lab at NASA's Goddard Space Flight Center. This lab specializes in custom materials to protect sensitive spacecraft equipment and is perfect for creating a ZGI that meets the rigorous safety standards of NASA.
Because you have to be concerned with whether the thread's going to outgas or if it will hold up, if it's flame retardant. This is the Rise ZGI doll. All I have left to do is to close the opening here and hand sew the hat on, make sure its stuffing is stuffed in there. And we have our pocket here for the SD card.
And on that tiny SD card will be millions of names submitted to virtually join the crew aboard Orion.
The Nancy Grace Roman and James Webb Space Telescopes have very different approaches to studying the universe. Roman has an extremely wide view to capture as much of the cosmos as possible. Webb will peer deeper than any telescope before it to see more detail and farther into the past. These contrasts enable different science and help us answer separate questions about the universe. Beginning with its beginning. Webb will see galaxies that are extremely far away, whose light was emitted when the universe was very young. It will reveal an early universe that scientists have only explored through calculations. We have very little information about the cosmos' infancy, and Webb will help us fill in many of the gaps by making direct observations of galaxies as far into the past as physically possible. Roman, on the other hand, will use the power of its wide sky coverage to survey massive regions of space, documenting significant portions of the universe through its adolescent and early adult years. Not only does Roman have a field of view 100 times larger than Webb's, but its compact and rigid design makes it more nimble, able to quickly repoint that wide view to survey large regions through a process called tiling. Roman will be able to survey thousands of square degrees of sky during its primary mission, enabling studies that were never possible before. Only by studying millions of galaxies can scientists begin to determine the behavior of the universe as a whole, like its large-scale structure and how it has changed over time. Dark matter and dark energy are both large presences in the universe that are only detectable through their effects on normal matter. The brightnesses of faraway supernovae work to measure the distances of galaxies and how dark energy is pushing them apart. The precise shapes of galaxies serve as a way to study the dark matter around them, but these features must be measured very accurately to be usable. Roman's hardware is particularly precise and well understood, so the data it collects is especially good for the statistical analysis required, giving scientists a holistic view of how dark matter and dark energy exist and affect the visible universe. Previous great observatories, Hubble, Chandra, Spitzer, and Compton, greatly expanded our understanding of the universe. Some of it was in ways that scientists and engineers had anticipated and designed the telescopes for. But many other discoveries were unanticipated, as the great observatories revealed new aspects of the universe and scientists discovered creative ways to use these powerful tools. The same will be true of both Roman and Webb. We can anticipate some of what they will show us, but many of the most exciting discoveries are the ones we can't predict.
This is showing aerosols. Now, those are tiny little particles in the atmosphere. You see the movement of air masses and aerosols between continents. You see the formation of weather patterns. You see how these kinds of sources like fires are changing over time and influencing the air that we all breathe. One of the most direct things that we care about is their impact on human health. So certain types of aerosols are very damaging for human health, for people's ability to breathe. Scientists and researchers will use models like this to understand the risk for different populations and prepare communities around the world for meeting the challenges of changes in air quality. Another important aspect of aerosols is their influence on thunderstorms and rainfall patterns. Their presence can affect the intensity of storms and the formation of different types of weather phenomenon. So what you're seeing in this visualization is these tiny aerosol particles that are actually color-coded by the type of aerosol in the atmosphere. So in this visualization, the green is sulfate aerosol that comes from things like power plants, volcanoes. The reddish color is carbon aerosols. Those come from a lot of different fires around the world. The purpley color is actually dust that comes from most notably the Sahara and lots of other deserts around the world. And that blue color is sea salt aerosol that's coming from ocean spray. NASA's developed some of the most complex, detailed aerosol models in the world. And this is really important. Satellites let us see the total amount of aerosols, but they can't always tell us in great detail where that aerosol came from. Visualizations like this really help us understand intuitively how those aerosols might have gotten to a place that's different from where they were emitted. We actually had a colleague in Australia write to us about a previous visualization and say, I actually never knew how this air mass got to Australia, and because I saw this in a movie, I understood that this air mass had been lofted by thunderstorms in the mid-latitudes and actually transported by high winds at a higher altitude. So there's all kinds of things that we learn when we actually pair the power of visualizations, the power of what we can see, with all of the science behind the models that go into this. You also see this interplay of all of the different kinds of science we do, of vegetation, of fires, of weather patterns, of atmospheric chemistry. That's the beautiful complexity of all of the things that we do at NASA, and why it's really important to have this innovation across observations, modeling, computing, and visualization to bring this all together so that we can use it and share it with everybody who's watching this today.
In this data visualization, you can see an earthquake strike under the Pacific Ocean in purple and the tsunami it generated in white. The red, orange, yellow, and green ringlets you see here are in part atmospheric disturbances caused by the event. Every ringlet you see is a real-time reading from ground stations around the globe. The disturbances were picked up by NASA's experimental system Guardian just 8 minutes after the earthquake. In Hawaii, Guardian flashes red and orange as it picks up the incoming wave, 32 minutes before the tsunami makes landfall and is detected by the tidal gauges seen here in blue. There's no stopping a tsunami, but NASA's Guardian could provide communities precious time to prepare.
Just everything from the training, but in 3D and absolutely unbelievable. This is incredible.
Kathy Moonjoy.
I definitely see all of the basin of Oriental, Copernicus, easily all in view. This is so awesome.
We look like we're smiling at you, like a little Cheshire cat. I thought we just caught an ActiWatch sync. If I had my own, I'd sync it with you. Breaking news. At this time, you are go for all types of uses of the toilet.
And the crew rejoices. Thank you. We caught a view of Earth in window 1, and now we're completely distracted for a little bit.
To me, is a great, example of why we go and do these missions. If you can't take love to the stars, then what are we doing? Like, why would we even go?
The sky is vast and unyielding, a canvas of infinite mysteries. It has always called to us, leaving whispers of forgotten truths written in the light of distant stars. But light, it seems, is a fleeting thing. Some of it we see, much of it we do not. For a time, we glimpsed the cosmos only as far as our eyes could take us. But now, we have forged instruments of power, telescopes that push past what the ancients could only dream of, revealing the hidden truths of the universe, patiently waiting for us to find them. One stands as a watcher in the void, a sentinel of time, Hubble the steadfast, which has gazed into the deep for more than 3 decades, its unblinding eye unraveling the age of galaxies and the dance of dying stars. Beside it, a younger vision, Webb, the seer of shadows. With golden sight, it peers into the dim glow of the earliest worlds, revealing the birth of stars, the breath of distant planets, and the echoes of the universe's first dawn. And there is another on its way, Roman the deep-sighted, armed with a gaze as broad as the sky itself. It will map the heavens with relentless precision, seeking the unseen forces that shape the cosmos. Yet even these 3 great sentinels cannot stand alone. Another will arise, a telescope of great purpose that is yet to be built, the Habitable Worlds Observatory, a beacon for those who search the stars for another Earth, and a torchbearer for discovery itself. From the birth of galaxies to the fate of worlds, its gaze will pierce the unknown, revealing the forces that shape the cosmos and the places that others might call home. Each of these instruments, mighty in their own right, wields a unique power. One sees the universe in the piercing clarity of ultraviolet and visible light, another in the ancient glow of heat, another in the vast sweep of the sky, and soon one will rise to seek the light of distant worlds. A group of visionaries, bound together, destined to spread knowledge, to push beyond the darkness, to forge a future where the unknown becomes known. From their posts in the void, they do not speak, but they watch, they reveal. It is the work of countless minds, scientists, engineers, and the dreamers who push the boundaries of what is possible. Their ingenuity forges new frontiers, advancing technology not for conquest but for understanding. With each discovery, they expand the reach of humanity, proving that even among the infinite, our pursuit of knowledge knows no bounds. And though the road goes ever on and on, though shadows still veil the farthest corners of the sky, the fellowship of the telescopes endures.
Stretching across the top of our planet like a verdant green crown, the boreal forest is Earth's largest forested biome. Home to moose, wolf, caribou, bear, and countless other species, this vast wilderness of spruce, fir, and pine holds more than 1/3 of the world's forests and stores massive amounts of carbon, helping regulate our global climate. But this forested frontier is changing, and for years, scientists could only theorize about how. The Earth system is complex and dynamic, with feedback mechanisms that can drive positive and negative outcomes.
For decades, there have been ecological and climatological models that have theoretically predicted that the boreal forest, given climate change, should be moving north.
Previous studies provided hints, regional evidence, indirect measurements, but the boreal forest changes slowly, very slowly. To truly see what's happening, you'd need to watch the entire forest continuously for decades. So how could researchers possibly test this hypothesis at such a massive scale? Enter Landsat, NASA's longest-running Earth observation program. For the first time, scientists could analyze the entire boreal forest using the complete Landsat archive.
This study is the first and only study to comprehensively study the entire boreal forest from 1984 to 2020 using 224,000 Landsat images, mapping the tree cover in every pixel, 30-meter resolution, and then testing whether or not the boreal forest is moving north.
The research team, led by NASA and TerraPulse, calibrated Landsat satellite data using NASA's airborne field campaign LiDAR measurements and commercial images to create the most accurate map of boreal tree cover ever produced. They then tracked changes in every 30-meter pixel, an area about the size of a baseball diamond, across 36 years in the entire circumboreal region. The scope is staggering, analyzing the complete northern forest belt spanning Alaska, Canada, Scandinavia, and Russia.
The study's groundbreaking just in its sheer scope. The longest record, the highest resolution. The data were calibrated using LiDAR. Just every resource was thrown at this study to get the final definitive answer.
And the answer is clear. The boreal forest is shifting north. Between 1985 and 2020, the forest's median latitude moved northward by 0.43 degrees, roughly 60 kilometers. The forest also expanded by 844,000 square kilometers, a 12% increase. And it's getting denser, with tree cover increasing across most latitudes.
What we found is that the forest is getting denser across most latitudes. At the very southern edge of the boreal forest, there are a couple slices, latitudinal slices, where the net change of the forest is being lost. But the pattern of those losses is pretty consistent over time, and those changes within latitude across time aren't really changing as much as the growth.
The boreal forest's northward shift affects everything, from managing fuel load fire risk to industrial operations of timber, oil, and mining, extracting resources across North America and Eurasia. It changes wildlife habitats and the forest's ability to store carbon. The expanding forest is also getting younger, with fast-growing trees that could sequester additional carbon if allowed to mature, a potential positive outcome of warming and climate benefit. Yet other factors could drive negative outcomes, which requires additional studies.
The boreal forest is poised for a major transition. Permafrost is thawing. The forest composition is changing. All of these things can lead to an abrupt shift in the ecosystem from one type to a completely different type. With shorter term or less calibrated data, we can see abrupt changes. But with the long-term, highly calibrated Landsat data, we can see the slow changes. It makes it sort of a canary in the coal mine. It's a slow canary, but if we have the long-term, high-resolution, highly calibrated data, which Landsat gives us, then we can listen to its song.
This research represents the most comprehensive analysis of boreal forest change ever conducted, made possible by decades of Landsat observations and NASA's commitment to understanding our changing planet.
Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
Ever since NASA's Parker Solar Probe launched into space in 2018, it has been circling closer and closer to the Sun and taking images along the way. In December 2024, it made its record-breaking closest approach to the Sun. That's when it took these historic close-ups of the solar atmosphere, images that are changing the way we understand our star.
With images like these ones, we are actually going to have this full understanding of how the solar atmosphere works, and in particular, to try to predict the solar activity and mitigate its impacts.
The images were taken by the spacecraft's Wide Field Imager for Solar Probe, or WISPR, which observes space in visible light. WISPR doesn't look at the Sun directly. Instead, it captures solar material just as it comes off of the Sun. When it took these images, the spacecraft was only 3.8 million miles from the Sun's surface. If Earth and the Sun were 1 foot apart, Parker Solar Probe was about half an inch from the Sun. At that distance, the spacecraft was immersed in the solar atmosphere known as the corona. Here, streams of electrically charged particles flow outward from the Sun at over 1 million miles per hour, forming the solar wind that fills the entire solar system. These images reveal previously unseen details at the origin of the solar wind.
The amount of clarity and the amount of details that we got from Parker Solar Probe is totally unprecedented. But also we see phenomena that you didn't really see before, and that's where the fun begins.
If you look closely, you can see key features in the images. This is a collision of 3 large outbursts of solar material known as coronal mass ejections, or CMEs.
The most impactful events, multiple events that are one following the others. And understanding that interaction between CMEs will help us also have another view of their potency for space weather.
When the most impactful eruptions reach Earth, they can trigger auroras, but they can also harm satellites, disrupt power grids, and expose astronauts to dangerous radiation. On the far left, there's another key feature. This region marks an important structure known as the heliospheric current sheet. If we zoom out and look at the Sun from the side, the current sheet looks like a twirling skirt that extends out from the Sun and across the solar system. This invisible current sheet is a boundary separating where the solar wind's magnetic field changes direction from north to south.
It surrounds the whole Sun, and it never disappears. That's actually one of the regimes of the solar wind that we have to understand.
The current sheet is important to study because it can affect how impactful eruptions can be at Earth. We've never seen these phenomena in such detail before, and scientists are continuing to study these images to piece together how the Sun affects Earth and the rest of the solar system.
Parker Solar Probe is opening our eyes on a new reality about our star, the Sun. It is rewriting the textbooks for us.
We have a standard model that is exquisite at describing the properties of the universe that we live in. But there are hints of a problem with that model. Roman will tell us if our model is wrong.
Andrew, are you ready to go?
You're good. We're ready.
And what's spectacular about Roman is Roman will be able to tell us if we were wrong and put us on the path to figuring out what's right.
Starting run.
This time, a year from today, we're going to have a different understanding of the universe than we have right now because of the observations from the Nancy Grace Roman Space Telescope.
Control reports test complete.
So the most exciting thing to me about Artemis 2 is just the return to the moon. We haven't been there in 50 years. Human eyes are going to see parts of the moon that haven't been seen by anyone before. It also recommits us to exploring the solar system in a way that we haven't in a long time. And I think it provides an opportunity for younger generations to understand the excitement of doing that kind of exploration. The moon is this great sort of chiaroscuro subject because the most recognizable thing about it is the changing sun angles and how that brings out the shape of craters near the terminator, which is the day-night line. Because there aren't, oceans and clouds and all the things that you see on Earth, the moon is really all about its shape. And the shape is telling you something about its long history and the history of the entire solar system. All the things that have happened to the Earth have been erased by geologic processes and weather and climate, and that doesn't happen on the moon. The moon has recorded everything that's happened since its formation almost 4.5 billion years ago. That tells us a lot about where we came from, where the solar system came from. It also reveals something about the composition of the Earth that we can't see because it's buried beneath the crust. Some of that is on the surface of the moon because it's been excavated by all the impacts. Artemis is our return to the moon after 50 years. The emphasis of Artemis is going to be, first of all, science, but second of all, learning to sustain a presence on another world. First on the moon, but we're hoping that that's a stepping stone to Mars and other destinations in the solar system eventually. Artemis 2 will be a flyby mission. It's not going to land. We're testing all of the technology that we've created for flying to the moon since Apollo. A lot of systems have been modernized, and we need to make sure that all of those work. The astronauts will be looking out the window at parts of the moon that have never been seen by human eyes before. They will be flying by the moon at an altitude that's much higher than Apollo's orbits. And so they will see the entire disk of the moon, including areas that are closer to both the North and South Pole that astronauts from Apollo never saw. All of that depends on the lighting, which we really won't know until launch day, but we can practice with different lighting scenarios. It's hard for people to sort of picture that in their mind. If you can make a visualization of it, show them a movie, that helps everybody choose the targets and also practice aiming at those targets. The astronauts have actually been looking at these visualizations through the lens of the camera and practicing aiming at the various targets. This is a map of the surface of the moon, obviously, but it shows what the Apollo astronauts could see in sunlight while they were in orbit. The brighter parts are the parts that they could see. The darker parts, like this entire area here and places that are farther north and south, are places that they couldn't see in sunlight, either because it was nighttime there or because it was beyond the horizon of the astronauts. All of the Apollo flights orbited the moon at a distance of about 110 kilometers. Because the astronauts were flying at such a low altitude, their horizon was actually quite close and they couldn't see the North and South poles. And this whole area over here was not in sunlight at the time. And it includes this amazing impact feature here called Oriental. Oriental is a very large impact feature. It's about 650 kilometers wide. It's got multiple rings. These are rings that form like ripples in a pond from the impact, but of course it's on a huge scale. The middle of Oriental has that sort of dark basalt lava covering it, like the dark spots that we see on the near side. It's one of the biggest ones that's more on the far side than the near. So seeing it with human eyes and sort of picking out features that maybe you don't even see in robotic cameras is an important goal for the mission. One of the photographic targets that is on everybody's list is pictures of the Earth beyond the limb of the moon. During Apollo 8, on their fourth orbit, they finally turned their spacecraft around so that they could see in the direction of the Earth.
Oh my God, look at that picture over there. Here's the Earth coming up. Wow, that's pretty. Hey, don't take that, it's not scheduled. You got a color film, Jim?
I think it surprised all of them how beautiful and how human it was to see the entire planet Earth from behind the horizon of another celestial body. That photograph called Earthrise had a huge impact on the public because from space, you don't see country boundaries, you don't see some of the human problems that we deal with on the surface. And you also recognize that the Earth is a finite place. It's not infinite, it's not everything. It is a pale blue dot in the vastness of space. Artemis is going to have that opportunity once again. I anticipate that the astronauts will have the same feeling that the Apollo 8 astronauts did, and I think it will have a similar effect on a new generation of people who are watching this mission unfold.